Morning class. Today is August 30th. This is basically the kickoff for the third week for this class. And I want to share with you basically what to look for in this week so that we're all on the same page. What type of assignments, what type of things that are coming. One of the things that you guys should have received from me is a message from the STEM Center, the STEM club coordinator. He wants a meeting on Wednesday at 1 p.m. And you guys, of course, are invited. Hopefully you will enjoy yourselves and learn something out of it. So please read that message I sent with the Zoom link and everything. And that's one thing. The other thing also is that we have quite a few things this week that we need to touch upon. So we really have to have an understanding of what we are supposed to be doing. Of course, like every other week, let me share the screen. First of all, let me switch to student view so that you have a feel of how this looks like from your vantage point. And let me share the screen. Share. Again, this is week 3. And we have all of this basically components of this model that we have to take care of. This is week 2 review. Remember, we covered so many concepts in week 2 that it's you really need to focus on them. And that's why we have at least, this is from week 1, as a matter of fact, the quiz, but the homework is directly from week 2. So we really have to connect to those things and take care of these assignments. And we have to understand a little bit of the geometry involved, whether for the for the celestial sphere, basically. And the two key concepts are altitude and longitude. And the altitude is the position on the Earth from the equator all the way to the North Pole, and it's measured really in angles. And the longitude is actually around the circumference of the Earth, around the going on the whole side of the Earth, 360 degrees. And that too is measured in angles. So it's very important to have a notion into how to locate yourself on the Earth. And for that, there is a projection on the celestial sphere. And the projection on the celestial sphere is basically taking the equator on the Earth and projecting it on the celestial sphere to make it into some sort of a celestial equator. And that the point above you is immediately is the zenith. And that is really corresponds to your location on the Earth, your latitude and longitude. And the position of the object in the sky are actually, we use a different notation for it. We use the right ascension, which is equivalent to the longitude in a sense, but it's measured actually in hours. And we use also, instead of the altitude, we use the declination, which is again measured in the celestial sphere, going from the celestial equator all the way to a Polaris in this case, so that we have an understanding of that. And the other thing that we have seen last week also is the fact that the tilt of the Earth is the one responsible for the seasons in the Earth, and that's where the assignment is in here. It's all has to do with it. So you really have to take care of, you have to understand those key concepts. We are in a position around 40 degrees. As a matter of fact, where we are is about 38 degrees. That's why our north, basically the zenith is not Polaris, and actually Polaris seems to be tilted by 38 degrees because of where we are, okay? So that is basically some of the key concepts that you really have to understand. And again, this week's discussion, I'm going to come to it. There are 4 units as opposed to the previous 2 weeks where we have 3 units only of reading. In this week, we have 4. So we have to have those concepts, all of them. The concepts for this week, and I'm going to talk about them, deal a little bit more specific concepts that were, let me make sure that it has to do with the calendar. Let me pick them up, okay? So the lunar cycles is one of the concepts for this week, and we're going to talk a little bit about them. And then also the calendar, as I was saying, And the geometry of the moon, Earth, and Sun, basically the eclipses and all of these key concepts on how the moon revolves around the Earth. And Unit 11, which is the last unit of this week, deals with the planets, okay, in general, and how that has an implication on our basically calendar and our weekly basically weeks and so on and so forth, how we measure time in general, okay, on Earth, and the influence of astronomy on culture, religion, and basically everything that, and agriculture and everything else, okay? So it has tremendous implications on a lot of things. So that's basically what we're going to be discovering in these 4 units. I'm going to talk briefly about each and every one of these units. Of course, next week, week 4, we're going to have a summary of this week. So this does not excuse you from reading these units. Do not again rely on the PowerPoints that I am listing in here. This is just some sort of a guidelines. You are still required to read them because come quiz time, you will be accountable for those concepts. So the reading is a must. And if you have any questions, again, please do ask. Again, the quiz is from week 1, as a matter of fact. Let me click on the quiz if it allows me to open it. I don't know. Hold on. I'm still as a student. Okay. So you have 30 minutes to complete the quiz. The quiz actually has 12 questions only. Okay. Some of the key concepts that you have to note is because sometimes they cannot, in the questions, they cannot, we cannot write 10 to the power something, something. Okay. So instead, and I make a note of it in every question so that you guys see that we use this, the caret symbol, 10 caret -3. So if you're wondering what that caret means, it means the same thing as in here, okay? So that's one of the things to look for during when you take the quiz. You will have 3 attempts at it. Canvas will take your highest score out of the 3. And here is the deal. You cannot take the quiz immediately after the first attempt, or any attempt for that matter. You have to give it some time before you come back to it. So if you decide you're not happy with your grade, my recommendation for you is to go back to week 1. And there are 3 units in there. Review the units, not from the PowerPoint, but rather from the book. Go through the entire units again. There are 3 of them, not too many. And it's about less than 15, 20, 16 pages. So you should go through them, understand them. And if you have any questions still, please let me know so that we can discuss those questions, those things that are of concern to you. Excuse me. And then take the quiz again. Okay. If you still are in doubt about it, I mean, your grade is not what you hope to see, because again, it's not penalizing you for the attempts. It's just take the highest score. So even if you are satisfied with the grade, but it is not a perfect grade, you still can take the 3rd attempt. Again, you really need to take the space and the time between them to allow yourself a full, basically, review to come back with the answers. Now, the reason why I'm saying that is because the questions are not the same. So when you take the 2nd attempt, the questions are not the same like the 1st attempt. So do not think that you took the 1st attempt, now you memorize or the questions so you can come back to them and now you know you have a better guess into what the answer is. That's not going to work because you're going to be confronted with different questions. So unless you really truly have read the chapters and have a full understanding of them, you will not really have a nice time with this question. So that's basically my advice for you guys. Now, the concepts covered in there is from the first 3 units, and the concepts have to do with the measurements of the system of measurement, the MKS system. That's the metric system, meter for distance, kilogram for mass, and time second. Okay, so these are the concepts that revolves around. Any other system of measurements like the imperial system, the food, the the mass is in pound and other units is not part of the MKS system. So it's going to be asking you that. The CGS system also is another system used by scientists, and it's not one of the questions that you will have there. The CGS system, if just to give you an idea, it uses a centimeter for distance, not the meter. It uses a gram for mass, not the kilogram. It still uses a second for time. And it has actually some other units, like, for example, the dyne for the force and the erg for the magnetic field and all kinds of other things that are different than the metric system. The metric system actually has another fundamental unit, which is the ampere for the current, and from there everything else defines about it. So if you see a question asking you about the metric system, you have to understand it has one or more of the following letters: M, K, Kg sometimes, and S, and potentially A. Okay, if it doesn't have or it has other letters than this, or it does not have any of this, then it's not a metric system, it's something else. The other thing also you have to be watchful for is the standard units for astronomical distances. Like, for example, the distance from the Earth to the Sun is a standard astronomical unit. That's 150 million kilometers. The other thing also to watch for is the light year, and that is a distance the light travels in 1 year, which is roughly about 10 to the power 10, or 9 times 10 to the power 9 kilometers, but 10 billion kilometers. Okay, so that is basically roughly the number. The other thing number also to watch for is the parsec, or the parallax second, which is an arc distance in space, and that is 3.26 light years. So it's slightly more than actually 3 compared to the light year. So the light year is a big distance, but it's still, the parsec is slightly more than it, 3 times, slightly over 3 times more than the light year. So those are some of the units that are measured, for measuring distances on astronomical scale, because of the fact that the distances are huge. In terms of masses, we use, comparatively speaking, the mass of the Earth when we're comparing, for example, objects in the solar system. Not too much, but the mass of the Earth is about 6 times 10 to the power 24 kilograms, which is a huge number. But this is not that much compared to the Sun, which is 2 times 10 to the power 30 kilogram. Okay, so again, this is some of the numbers that we have to basically think of. We compare usually the radius of the Earth, which is 6,400 kilometers, to the radii of different objects in the solar system. For example, how many Earth radii are in Jupiter or in Mars, which is slightly less than actually the Earth, and so on and so forth. So that's basically the numbers that we have to, you have to be familiar with, the concepts that you have to be familiar with for this quiz. Again, this is not in lieu of reading those chapters and understanding them. Still, I'm sorry, units and understanding them. The book, it doesn't call them chapters, it calls them units, and actually it has divided in different parts. So it's still part 1 of, and we're dealing with this units in it. So again, so these are some of the key concepts that you need to take care of. Since I'm not a student, I mean, this is just a test student, I'm not going to begin the quiz in here for you guys. So I'm assuming that you can do that. And if you have any questions, please let me know. Again, the homework, I'm going to click on it right now. And this is worth 10 points. All of this have deadlines, okay? So don't forget the deadlines. So again, it's worth 10 points. And it's on Saturday, September 11th by 11 p.m. That's when the assignment is due. The text, if I started right now as a student, let me show you something slightly different than what we've been using. So if I started as a student, I have the option to upload a file, or basically use the webcam to upload a video. Okay, post my answer there, or insert it in here. So you have all kinds of options in here, including text entry in here. Okay. And however you would want to basically upload your file. So that is one thing. The other thing also is that the two questions that are coming are from 12 and 13 only from page 50 from the book. And it doesn't matter which edition you have. I looked at both editions, they both are on the same page and both of them are the same number of problems. So they are the same, identical as when it comes to this question. Again, when you're answering these questions, you have to use complete sentences. So if it asks you, for example, a specific number, 12 divided by 50, do not tell me the answer is 0.24. Okay, don't write 0.24. You have to put a little bit more explicit. I mean, the question in this case, it will have significance. It is asking you, for example, ratio of something over something. Obviously, these questions deal with the seasons and the tilt of the axis of the Earth. So you have to make sure that your questions are in complete sentences. Short answers will lose points, okay? So you have to answer in complete sentences. And then you can and should work in teams. That is something that we discussed last week. And you must include the name of your team or the names of your team members. So remember from last week when we said the team cannot be really too big. I mean, at most 3 to 4, okay? 2 and 3 is good, but not one person is not really good. I mean, if you have to, that's fine, but I really want you to be paired at least with another person, if not 2, so that you are 3 of you working on this assignments. And you exchange ideas and so on and so forth. Now, a team that is more than 4 is really not recommended. It is actually against the, I would strongly discourage that. Okay? Do not work in a group of 10 or 12 or even 16 people, because you'll be lost. You will have no idea what the other people are doing and they don't know what you're doing. And then it's really not a team anymore. It's really, so 3 to 4 people at most, okay? That is what a team in here is. You can submit, as I was saying, your work. You can write it on Word and upload the file and be done with it, or you can use any other format, actually, text format, whatever format you have in there. Take a picture after you work it out with your pen and paper, and then take a picture and upload the picture. When you do the picture, please be careful of the following 2 things. First of all, the lighting. It's a good idea to have a light behind the whole thing so that you'll have a clear picture behind the screen, actually, so that, not the screen. If this is the paper I'm writing on, then I will have the light coming this way so that it shines on the area where I am taking the picture. Now, the other thing also, it's a good idea to look at the picture yourself and see, is this picture visible or not? Okay, and if it's not, then let me pause the recording quickly because some of you are messaging me, so I don't know if this is a, let me stop sharing first and pause the recording. Again, there maybe seem to be, at least for one person, they were not finding the Confer Zoom, so the link. So I'll try to troubleshoot what that problem is and then send you more updated, basically, information on it. Again, let me stop sharing the screen. Right now, we went through all of the things that needs to be done for the homework assignment and for the quiz and the discussion item for today. And then let me go through this quick object. I did not ask the question yet, so if you're wondering, we don't have the discussion item yet. So let me stop sharing the screen. Oh, I was not sharing it. I'm sorry. I left it earlier, but it doesn't matter. So let me leave the student view. Come on. And let me pull this information in here. And let me now share the screen. Sorry about that. Anyway, so the key concepts for this week are, again, from the first one is the lunar phases. It's very important you have an understanding of that because we will have an assignment, also a big one, coming on that. Again, the relative position of the Earth, the Sun, and the Moon will give me the different lunar phases. Either a new moon, if the Earth happened to be between the Sun and the Moon, or a full moon if the, what did I say in here? Yeah, or a full moon if oh no, it's the opposite. Okay, the full moon is when the Earth is actually we have the moon in here, the sun is shining on it, and we see it, or the new moon when it's the opposite direction. And then we have the quarter moons, the gibbous, basically moons that is waning or waxing moons. So those are the basically different cycles that you're going to be looking for, and the different positions of the moon in the sky with respect to these objects. One thing that I want you to look at, and it's this table in here. Let me first of all find it. This one in here explains more or less the different locations for the lunar eclipse, and whether or not or the solar eclipse, and whether or not they happen or not, because of the fact that the Earth revolves around the sun like all of the other planets on the same plane, okay, the eclectic plane. Now, the moon has its spin or rotation around the Earth in an axis, in a plane that is tilted with respect to the ecliptic. That's why sometimes, like for example, in this position, we have the moon can be on either side of the Earth, but we will not have neither a solar eclipse nor a lunar eclipse, because actually the moon either above the plane of the Earth or below the plane of the Earth, same thing in here. But sometimes we will have that when actually the two planes cross each other. The ecliptic plane where the Earth is going around the sun, like most of the planets, and the plane around which the moon revolves around the Earth. Once they cross each other, that is when we see either a solar eclipse or a lunar eclipse. What is the lunar eclipse, okay? One of the two. So those are the two events that can lead to that, okay? Lunar eclipse or solar eclipse. So those are the two conditions under which. That is because of the tilt in here. So hopefully this is, you're going to read this chapter. If you have any questions, please let me know. Let me stop sharing. I'm not sure if you guys are looking at this or not. Let me stop sharing and share the screen in here. Again, this is Unit 9 from this week. And this one talks about the calendar in general and how we arrived to it. First of all, we have 5 days of the week corresponding to the 5 bodies in the sky that we put. 7 days of the week corresponding to 7 bodies in the sky. Okay, we have the day of the moon, Monday. We have the day of, what is it? Tuesday is the day of Mars, actually, Tuesday. And we have, I mean, it's coming from Latin, okay, not from English. The day of Wednesday, which is the day of Mercury, actually. And then the day of Jupiter, which is Thursday. And then followed by the day of Venus, which is Friday. And then followed by this day of Saturn, which is Saturday. And then followed by the day of the sun, which is Sunday. So those are the 7 days of the week based on the 7 objects that we see around the Earth moving that often, and those are the days that we have. The word month itself derives from the lunar month, from the moon itself. And again, the lunar month and the actual solar month are very close from one another, 29.5 day. And there is actually another concept that I did not talk a lot about, but hopefully you guys will capture during your reading, and that is the sidereal versus the solar or the lunar month. And those they have to do with basically the position relative to the stars. Sidereal is usually the real basically rotation around a distant object, which will give me a full cycle. However, because of the rotation that we have to adjust for it, because of the movement that we have to adjust with, but usually have to wait a few days or hours, depending on what we're looking for. If it's a day, hours, if it's a month, it's days, to make that adjustment, okay? So that is one thing that we have to look for. And again, calendars were used for all kinds of things and all kinds of religions. The 3 religions that really have cemented this one, of course, the Jewish faith and the Christianity and also Islam, in a sense that they brought all of these concepts and they have all kinds of basically marked days in the year to celebrate this special religious events, and those they actually cemented the idea of the calendar. Again, even the Gregorian calendar is related to the lunar calendar, especially in terms of division of the year in 12 months and so on and so forth. So that's the connection with religion. The connection with culture is also there. Whether you explore the history, and you will see that even even religions or other basically cultures other than these religions also, they have had use of the calendar, and they have divisions similar to this ones. Again, it has also to do with the agriculture, and hopefully you guys can read through that and have an understanding of it. Good thing that Uranus and Neptune were not known to the ancients, otherwise the week will probably have 9 days in it, okay? Because Uranus and Neptune were discovered later on, okay? Otherwise, they would be included probably, okay, in the week, and we will have a 9-week, not a 9-day week, not a 7-day week, okay? The way we have it in here. You need to read about the Gregorian, basically date, and how the idea of the leap year basically has been invented to make for the correction of the rotation of the Earth around the sun, and why we have some years with 29 days for February and 28 days for the other years. Okay, that's this unit. Let me go through the unit again. This is an important unit, okay? This is a very important unit that you have to understand. First of all, why did the ancients think that the Earth is round and not flat? And they had very solid arguments for it, okay? Starts from Aristotle to all kinds of philosophers that when they looked at for example, the solar, the lunar eclipse, and they saw the projection of the Earth on the moon, it looks round on the edges. So from here, they concluded that the Earth must be a spherical object. Furthermore, as the objects fall in below the horizon, then that is actually another indication that the Earth is not really flat, but rather it's spherical, because as you move along, the things that fell below the horizon starts to appear again. Okay, so they fall gradually, and if you move toward them with a boat, you will see that the land shore starts to appear little by little until it comes to view, because now you're going around the spherical object. And again, also they were actually able to measure the radius of the Earth with tremendous accuracy, relatively speaking. So not only that it's spherical objects, but how big is the distance from the center to the Earth? Actually, they measure the circumference. From here, you can induce the radius of the Earth. And it was amazing, basically, to think of how they did it, actually, in modern day Egypt. So basically, if you go around the south of Egypt in old day Cyan, you will see that at some time in the year, the sun is immediately above your head and casts zero shadow on you. So if you look at it that way, there is a zero shadow on the same time of the year. If you go to modern day, it says the same day, it's same city, Alexandria, you will see that there is a shadow of about 18 degrees on the same day. So from here, you can calculate the circumference of the Earth if you know the distance that you have to travel. Came up with an amazing measurement. Of course, they use stadii, which is how many stadiums you have, and that's the biggest probably distance that they have used in there. And that corresponds to the circumference of the entire Earth, because you just calculated an arc, and from here you extend it for the whole circle, which is 360 degrees instead of 18 degrees. So it's amazing. The other thing also, since we know the size of the Earth, then we can estimate the size of the moon to see how many shadows are cast around the moon, or the moon casts around the Earth, or the Earth casts around the moon during the lunar eclipse. From here, you have an estimate of the size of the moon, which was about 1/3 of the radius of the Earth. Now, if you know the size of the moon, and all you need is a quarter or nickel, and take the nickel and move it from your eye. until it covers completely the moon. Not too much, because if you move it closer, it's going to cover more than you need. Not too far, because it's going to cover little. So there is an ideal distance that you take. For example, it doesn't matter which coin you take. Okay, at that time, they didn't have nickels or quarters. They have different coins. So you take a coin that you know its diameter, and you move it closer from your eye. In this case, the coin will cover the entire moon and probably some. You move the coin back, back, back until you reach a point where it covers just the moon. Not more than the moon, just the moon. If you move it further, it's not going to cover the moon. Part of the moon starts to appear from the edges of the coin. So in this case, you move it closer to cover just the moon. At that time, calculate the distance from your eye to the coin and use simple geometry, which is a ratio of the angles, to find the distance from the Earth to the moon, 380,000 kilometers in modern day units. So you can measure it in terms of how big the radius of the Earth is. Now you know the distance to the moon. You know the size of the moon. You know the size of the Earth. Based on another observation, this is the ancients, this is the Greeks. Based on when the moon is a quarter moon, then if the ray of the sun is coming, hitting the moon and projecting itself back towards giving us a quarter of the moon, that is a 90-degree angle. And since we know that there's one side of the right angle triangle, we can find its hypotenuse if I can find the angle. So they measure the angle during the quarter moon, and from there they found the distance from the Earth to the moon. It's amazing on how much little you have, and you can do astronomical measurements. So they know the Earth is round. They know its radius. They know the radius of the moon. They know the distance to the moon, and they know the distance to the sun. All of this based on this calculations. Try to implement that to the size of the Earth. The moon, the sun, it came a little bit off, but it came with a high number too, because of its distance. In this case, it has a little bit of error. Okay, but that's a very good number, even for the size of the moon, the sun. So it's amazing of what you can infer. This unit is very important. I really cannot emphasize on it enough. Okay, the last unit that we're going to describe in here, describe the patterns of motion in the sky for the different planets and the different, again, this is also an important unit in here that you need to make, because it has applications also on another project you will be having. And this one has to do with the apparent motion of the skies around the Earth, around the apparent planets around the Earth, and the different positions, whether they are in opposition or conjunction, basically with respect to the Earth. Are they on the side of the sun or the other opposite side? And how that enabled Copernicus to measure the distances, or the distances of these objects from the sun. So if you know the distance to the Earth, which is about 1 unit, then using just this calculation from the quadrature, basically this is what I'm talking about in here. If you know this distance, the conjunction to the quadrature, if you know that how long it takes, you can estimate the radius, or how far the object is from the sun. This is the calculation, 0.38 astronomical units, which is 150 million kilometers times 0.38, a little over, about a little over a third. The actual measurement is 0.39, so it's very close from it. For Venus, it's right on the money. For the Earth, of course, that's the standard comparison. And then for Mars, also right on the money, it's accurate. Then for Jupiter, it's slightly off, but not by much. For Saturn, it's a little bit off, okay? But it's still very, very accurate. Instead of 9.5 astronomical units, we came slightly with more than 9 astronomical units. And it's really a very, very important calculation. So that just tell you, but that how much you can do just with observation. Of course, Copernicus spent a lot of time basically doing the measurements, but then actually used the measurements from before, and he came up with the model. Basically, there are two competing models, that the Earth is the center of the solar system, or the sun is the center of the solar system. And with his model, that the sun is the center of the solar system, namely heliocentric model, versus a geocentric model, which was before it prevailing to it. He came up with the explanation for a retrograde motion of the Mars, especially, which was really a big problem, because this is basically Ptolemy's explanation, that you have an object rotating in a circle around the Earth. That is the geocentric model. But in his model, that the sun is the center of the Earth, and the center of the solar system. And as the Earth and Mars are moving around the sun, at some point, if you're looking at Mars, you'll see it in the sky in this position. If you project it later on as the Earth is overtaking Mars, it looks like it's still moving forward. Then at some point, it looks like it has went backward. And then if you look at the Mars later on, because the Earth is moving faster, that's why you do that. That's why this Mars hardly moves while the Earth moves. So if you look at it now, it looks like it went back in the night sky compared to the background stars. So this is really the heliocentric model, and how that was able to explain the retrograde motion much better than the geocentric model, because it gave us actually an insight into Venus and all of the other objects. This is part of a big project that you guys are going to have. Again, I'm sorry that for some reason, some of you have problems with the link, and I'm going to share this recording with you guys later on. And the question that I want you really to really comment on is the fact that although we're not doing a lot of detail classes, even if we are live, we're not going to do that. You are still required to do the reading. Is make sure you do your reading for all of these units. You're going to be tested on them. So that is the prompt that I want you guys to put in the bottom in the discussion today. I was not sure if I was sharing the screen or not, but it doesn't matter. If you guys have any questions, please let me know. Thank you. I'm going to stop the recording.